Assalamualaikum and good day. Uh, Next, we gonna to do the quick revision on region of convergence for the Laplace transform. Um, um, this example, when the question give you the time domains, xt equal to exponent 2s ut. Right. First of all, what you gonna to do, you need to imagine where the signal looks like. UT represent as when uh, the signal happen when t from 0 until to infinity, unit step here. So exponent, we're gonna do the curve. So the curve only happen at the right side. So we know the exponent minus 2t ut is signal happen at the right side of the graph. So later on, after you identify the signals, the shape, then you can do the conversion of Laplace transform by using Laplace formula, and then you can reset up the limits. So from now limit is from 0 to infinity. So and then after the conversions and replace the domain, the limitations 0 to infinity, and then you got the value, the conversion is 1 over s plus 2. So to set the limit, we know the signal only happen when t more than zeros. So we can say that 1 over s plus 2 more than zeros, because the signal is right side. Right? If you bring up minus 2 to the right side, so we got the s more than minus 2. So we can draw the s-plane. So our pose at the minus 2. So because the signal only happen when s more than minus 2, so we shaded at the right side of the graph without touch the pose value. So we shaded the right side until to infinity, and then from this graph we can consider the system causal or stable. So as I mentioned, we stripe or we shaded the area more than minus 2 to the right side, and then it will touch the imaginary axis. So we can conclude that the system is stable when our straight line or the shaded line are touch the imaginary axis. Right, and this system also said to be the causal, because the system only happen, or the system depend on the current value and the past value. So because the signal at the right side, so we know that the system is causal because it depend on current and the past value. So this system said to be stable and causal, right? This is for and this for first cases, for example, and for the second example, we got the when the equation give you the xt equal to minus exponent minus 2t and time with u minus t. So we can, first of all, we need to do, to try to imagine the signals look like. The u minus t is a unit step at the left side. When 0 and to minus infinity, only signal happen in this side. Then the exponents minus 2t, maybe the graph is the curve to the right, the left side. Alright, after you considered, you figure out the signal looks like, and then you can do the Laplace transform, and then you can reset the limits. So we know the limit is start from 0 until minus infinity. Okay, so we put that exponent minus st, our input, uh, our transformation times our input, exponent minus 2t dt, and then after do the conversion, we got the um, result is 1 over s plus 2. So because our signal at the left side, we know that this system only happen when t less than 0. So by take the poles, so we can say that s plus 2 less than 0. So we know the signal s less than minus 2 when we bring the 2 to the right side. So we can plot the explained, and we plot the our pole here minus 2. So the signal only happen when the s less than minus 2. So we shaded the area when the uh, lower than minus 2. All right. Okay, if we got this system, we can uh, do a considerations and identify the type of the system. Okay, the ROC happen when the shaded area less than 2, and then we can say that the system is not stable because the shaded area not touch the j omega or imaginary axis. So we can say that signal is not absolutely integrable, and it a system is not casual, non-causality, because the system at the left side, so it's only depend on the future elements, not the past element. So we can say that the system is unstable and non-causal for the second example. All right. And then for the third example or third case, the questions give you two input, one input ut and another one input minus t. So we know that first input for the right side signal and the second input for the left side signals. So we need to do the two separate conversions. So after do conversion, I got the exponent minus t ut equal to 1 over s plus 1. And then this signal only happen at the right side. So s must more than 0. So we can take a pole s plus 1 more than 0. So s equal or s more than minus 1. So we bring 1 to the right side. So first, this for first poles, and for the second signal, we convert exponent 2t minus u minus t, and then we got the Laplace transform equal to 1 over s minus 2. So because the signal at the left side, we can say that the s must less than 0. So take the pole s minus 2 minus than 0, less than 0. So bring 2 minus 2 to right side, and then we got that. We know that ROC happens s happen when the less than 2. So for the first element, poles equal to at the minus 1, and the second poles is at the 2. So for the first poles, because more than minus 1, so we shaded more than minus 1, right? But not touch the element 2. The shaded area cannot overlap on the next pole, so it will stop on that area only. And then for the second poles, less than 2, so pole is 2, so less than 2, we shaded the next area. So not touch the next minus 1 pole. So we stop here. So now we can have two redundant shaded area. Okay, so we can say that the shaded area is only Laplace can happen here. Then the system can be stable because both a shaded area attach the uh, imaginary axis. So we can say that the system is uh, stable and absolutely integrable. And then the system can say to be casual. All right. For the last example, same like the previous, we have two signals separated. And first signal on the right side, and then the second signal for the left side. So after do the conversions, we can say that first element become 1 over s plus 4. We know that this right side must be happen more than 0. And then the second element we can convert it to 1 over s plus 2. And because this signal happen the left side, we can assume that the signal less than 0. So by take the pool element for the first signal, so s plus 4 more than 0. So we can say that s more than minus 4. And for the second poles, s plus 2 less than 0. So we can say that s less minus 2. Okay, we can draw the Laplace transform. So first element pose is minus 4, and second element as pole at minus 2. For the right side, more than 0, first the right side signal, so means that s more than minus 4. So we shaded uh, at more than poles minus 4. So we shaded here. And another element is s minus less than minus 2. So pole s minus 2, we shaded the area. So not touch the the the, the pole here. So we can say this only area only happen the uh, Laplace transform. Okay, means that the range is from minus 4 to minus 2. And then this system said not to be stable because this shaded area not touch the imaginary axis. So the system is not absolutely integrable, and the system only happen on the future, so we can say that it's non-causal system. All right, that's all for recap for the ROC causality and stability for the Laplace transform. All right. Okay, thank you.